compounds. Yesterday we have seen the hydrogen chemical properties. There is reaction with halogens, reaction with nitrogen, reaction with metals, metal oxides, reaction with oxygen, so many. And we have seen the many hydrates also of the that is hydrates of the metals and all. Interesting point is that some of the metal hydrates doesn't form a stoichiometric compounds. That means it will be some MH 2.6, 2.1, 3.1 like that. It will be non-stoichiometric compounds. They doesn't form the even basic stoichiometric equations also. Particularly the examples of the tantalum, zirconium, titanium, like this. One more interesting property of the hydrogen compound is the some of the metals, particularly the platinum and palladium, they absorb the hydrogen in their intestines and they will be acting like a hydrogen fuel cell. Very useful in the special applications. So these are the two exceptions in the hydrogen that one has. Now comes back to the very interesting the hydrogen compound is hydrogen oxide, which is nothing but water. The symbol is what we are is H2. Hydrogen, oxygen, water is available in the earth surface as 65% and in human body also 65%. And some of the very rare plants is having 99.5% also. On the earth crust, whatever it is 65%, out of 65%, 99.3% is on the oceans and sea only. And whereas 2% is available in both poles. So 99.3% is almost over. So remaining 0.7% is only what we are using or what we are seeing as a useful water, which is in the lakes, ponds, rivers, and the underground waters and all these things. Well, so hydrogen means water is having a special properties. Why H2S is one the most of the normal common question is why H2S is a gas, whereas H2O is liquid. That is because of the hydrogen bonding, which is having a tremendous effects on this, and it is keeping in the water H2O as a water form. And one more interesting is the H2O solid. That means the solid ice is having less density, so it floats on the water. So that is an interesting because of the hydrogen bonding, the boiling points, melting points, everything is very high for H2 and very useful these things also. And pure water is a pH is 7 and the conductivity is very low, 0.055 microsiemens per centimeter, and not 0 degree centigrade, and boiling melting point 100 degree centigrade at 1 atmosphere is the boiling points. Interestingly, hydrogen isotope form of hydrogen, deuterium, is also makes water compounds. Means that's called heavy water, D2O. This is H2O, that is D2O. But the D2O is having a very limited applications, that is in the nuclear applications and medical applications, whereas water is everywhere requires and all these things. Fine. The bond angle between the H and H is around 104 degree 5 this thing, and the bond length between O and H is the 95.5 pm, that is the picometers, and it is a dipole compound. Very useful. It is solubility is very high for the most of the ionic compounds and all this. Its physical properties, if one see, it is a waterless, tasteless, and the colorless, a liquid. Very miss, nothing is available. But what we are drinking is different, that will come later. Whereas the chemical property, if you say, it is acts as an acid, it acts like a base also. That means sometimes it is acts like a acid, sometimes it is acts like a base. So it is called amphoteric liquid. And its pH also depends upon temperature and other things. Next comes to the what we are drinking is a mineral water almost type. So from where these minerals are coming and what it contains, so is the cations and anions. Cations like calcium, magnesium, sodium, potassium, and all these things. Anions like bicarbonate, carbonate, sulfate, nitrate, and silicate. These are the anions which we are what we are drinking. This is coming because of this water is flowing all the way on the surface of the earth. Depends upon where it is flowing through this thing, or where it is located underground, or which pond it contains, and all this. This Ganga river water combination is different from Godavari, is different from Krishna, or different from a Hussain Sagar lake, or whatever it is. Depends. It is soluble in the cations and anions. So because of that, it is having minerals. Those are very much useful for the human body, and not useful also. Limitations are there. So how the drinking water and all these things, that is a separate story. In the water, we broadly categorize into the soft water and the hard water. What is meant by soft and what is meant by hard? Soft is nothing but the water which contains normally the calcium carbonate and all. By heating the water, it is going out, CO2 is going out, and that type of water is called soft water and all. Whereas sulfates, calcium sulfates and all these things, which is very hard water. That is hard means what is to be what is meaning by hard is when the soap is rubbing with the soap, you will not have any foam. That is all these waters are the soft hard waters. The calcium sulfate particularly, and silicates are there, lignite silicates are also there. So the properties and the how to purify for the industries, this pure water only we require. So whereas for the drinking we require the mineral waters. Whereas for the some other purpose, the sea water and all not at all useful for any other purpose. So water is used normally for in the industries, in industries also for the boilers and for the cooling water, for as a cooling in the domestic purpose, in the bath purpose, and for the agriculture purpose, for the drinking purpose. The enormous usages are there. Water, without water we can. See, we will see how to make the impure water, that means water softening, or the impure water making it to the pure water. We'll see tomorrow. Okay, thank you.